Hello, I am Seyi dhan Yilmaz.
Hello, I am Talha Güçlü.
Hello, I am Ali Kaymaz. This project is prepared in the scope of LF447 Microwave Techniques class. In this project, we are supposed to design transmission line and waveguide. We have 6 tasks to be solved. We have given 2 parameters. These are frequency, which is 3 GHz, and electric constant, which is 2.94. Let's start with the first task. In the first task, we are supposed to design a 50 ohm coaxial transmission line with given parameters. After the calculations that we have made theoretically, we have checked our results with a WRTX line calculator. Inner radius of the coaxial line is 7.16 millimeters, and the outer radius is 2.99 millimeters. The purpose of the second task is designing a matched line using single-stop short-circuit line, 3 different loads which are infinite, 50 ohm and 75 ohm loads. When the load is infinite, it means that the load is an open circuit. In this case, the reflection coefficient is 1 and incident wave is fully reflected. When the load is 75 ohm, the reflection coefficient is 0.2. When the load is 50 ohm, it means that the transmission line is already matched. In this case, the reflection coefficient is 0 and there is no reflection. Also, these calculations are proved by using Smith charts.
In the third task, the coaxial transmission line, which we have designed in the first task, is simulated with AVR design environment tool. Reflection coefficient, VSVR, input impedance versus frequency, and input impedance versus line length graphs are observed in specific frequency range. Either of them are consistent with our expectations. In the next task, we have designed a matched line using single-step short-circuit line with various loads. When the load is J75 ohm, it's not possible to match using a single step or a purely reactive load. When the load is 75 ohm, the reflection coefficient is 0.2. When the load is 50 ohm, it means that the transmission line is already matched. In this case, the reflection coefficient is 0, and there is no reflection. Also, these calculations are proved by using Smith charts, and this transmission line is simulated with AVR design environment tool.
In fifth task, we have designed a 50 ohm coaxial transmission line with R parameter with CST simulation tool. We have obtained a return loss of the transmission line for specific frequency range. For this graph, we can understand that the best frequency value for our material to work is nearly 2.5 GHz. In the last task, we have designed a rectangular waveguide with given dimensions by using CST. We have simulated rectangular waveguide for TA10, TA20, TM11 modes at 4 and 9 GHz. The simulations have done with different electric constants. We have observed that if different modes can propagate at different parameters. Thanks for listening. Have a nice day.